now we are testing the Albert Einstein's theory of relativity. This is a laser target, really cool. And this is a laser, don't shine it in your eye. So these are some things you're gonna need for this experiment. You're definitely gonna need the help with it. You have to take a large, clear, like a Pyrex container that you can make a lot of Jello in. This is 6 packets of Jello. Before you do that, you want to secure a mirror in there. We used like a clay substance to hold the mirror in there, pour the Jello in, and let it set. What we're going to do today is shine a laser through it and bounce it off the mirror at a 90-degree angle. Some other things you'll need: something to put our laser target on. This is going to be in your packet. You can cut it out and just find a way to make a stand for it. Okay, we just used a piece of cardboard, some duct tape, and a paper clip to set it on there. You might want to make it so you can move it up and down depending on where the laser is going to shine. You kind of want to get it right in the middle of the target. So you'll need tape. I'm using duct tape, scissors for the duct tape, a book. What the book is for is to raise the level of the laser. What we're going to do is we're going to tape down the button on the laser so it shines constantly, and we're going to tape it to the book so it doesn't move. And what we're doing here, back in the early 1900s, Albert Einstein came up with the theory of relativity, and what it predicted was that space and time kind of acts like a fabric or some kind of medium that things can propagate through, like waves. And he theorized that if two large bodies interacted with each other too much, like neutron stars that are orbiting each other, making the pulsar, it would create these waves that would propagate out throughout the universe. And so we tried to come up with a way to measure that. And what they came up with is called LIGO. We have one here in Louisiana, and I believe there's one on the West Coast too. What it is, it's a series of lasers that are bent with mirrors and very sensitive instruments that measure those to see if there's any movement in that. And recently they discovered that there are space-time waves that travel through the universe, and they can map out where they come from and their intensity. So what we're going to do today is we're going to simulate that with Jello. As our laser beams through the Jello, bounces off the mirror through the Jello to our laser target, we're going to bounce a metal ball off the Jello and see those waves come through as the laser moves on the target. Okay, so again, things you'll need: Jello in a large clear bowl, mirror in the Jello, so put it in before you set the Jello, something to put your laser target on, something to mount your laser and push the button down, which would be tape, and scissors if you need to cut the tape. It's some kind of a heavier type of object that you can bounce off the Jello, but not something that's going to break your bowl. Okay, so now we're going to get it set up and test it out. Okay, so now you can see our lasers propped up on the book, shining through the Jello, bouncing off the mirror and onto the target. Okay, now we're going to test these wave properties here. So we experimented with it. It didn't move drastically, but if you film it, you can see the slow movement of the laser up and down. And we even did a little bit of slow-mo video so you can see that. One thing that we had to do was move where we dropped the ball, and we even took our fingers and kind of made waves in the Jello. But the closer you got to the mirror, the more movement you could see. So that helped out a lot. So experiment with it, try it out, and see what you can do. Make sure you wash your hands really good when you're done, because mine are very sticky. Thanks a lot. Bye-bye.